Hi, I'm an old guy and I do maths, and in this video we're looking at combinations. Now, you normally deal with these at the same time as you deal with permutations. Now, there's a permutation video on this playlist. If you've arrived at this and you haven't had a look at permutations, maybe have a look at that first. Um, I think that that's the way to do it. Okay, so combinations. What's a combination? Well, it's an arrangement of things, letters, numbers, things, people, whatever, where order is not important. So the famous example that's usually given is if you go to an ice cream shop and you buy an ice cream cone which has one of those cones where they used to be called a double header when I was a kid. But they have a place for a scoop side by side, and you ask for a vanilla scoop and a chocolate scoop. And if you look at the ice cream from one direction, you have chocolate and then vanilla. But if someone is looking at you and the ice cream is between you, they're seeing vanilla and chocolate. It is the same ice cream. Order is not important. And that is the point of difference between combinations and permutations. If you watch the permutations video, you'll see me going on and on and on about how order is important. Here it is not. Okay. Again, if you've looked at the permutations video, this notation here will look vaguely familiar, but we'll get into what this means. Just to reiterate the point, order is not important as far as we're concerned. AB is the same as BA. Okay. Right, so let's look at a little example of this. So we have a set of 4 letters from which we must choose arrangements, combinations, call them what you like, of 2 letters. And if we do that in a way in which order is important, so that AB is the same as BA, what we get is we get 1, 2, 3, 4 times 3. We get 12 possible combinations. Let's put that more specifically. We get 10 possible arrangements. These are in fact permutations because order is important. Where order is not important, when AB is the same as BA, if you look down here, what I've done is I've taken out all the double ups, so to speak. So AB and BA are considered the same, so I've taken out that. BC and CB are the same, and so forth and so on. And so what we find is that instead of there being 12 in this group, where order is not important, where BA is the same as AB or BC the same as CB, that number is considerably reduced. In this case, it's halved. And there are 6 possible combinations of the letters A, B, C, D, where order is not important. First important lesson. Okay. Moving along. How do we define a combination? It's the number of permutations, there should be an S in there, of n objects chosen R at a time. So R is the number that we get to choose. In the previous example, we had 4 objects. We could choose 2 at a time. Now, again, those of you who've seen the permutations video will recognize this first bit. What happens when you deal with a combination where order is not important is that you have to do one further step, which is to divide this by R factorial. Now, that probably doesn't make a huge amount of sense until you take a look at these formulas. Now, a combination NCR can be written like this. It is the permutation formula divided by the factorial of your choice. Okay. So, just to refresh memories, the permutation formula is this: n factorial over n minus r factorial. And what we're doing is we're dividing this one more time by r factorial. So, the formula for a combination NCR, or N choose R, where order is not important, is n factorial over n minus r factorial times r factorial. It's this little addition here that makes all the difference. And for those of you who have had a look at binomial theorem or other elements of probability, this can be written like this, and you will have seen this in binomial theorem. But that's not something that we specifically touch on today. Okay, moving along. Let's find an application for this. So this is the example that I used with permutations. We had 5 objects, the letters in the word train. And we could choose 3 at a time. So we could choose AIN, TRA, whatever. The point being that if we chose TRA, with a permutation, ART is a different choice, but with a combination it is not. TRA is the same as ART, or RAT, or whatever. Okay, so let's go to work. So we have 5 objects, we choose 3 at a time. That's 5, choose 3. N is 5, R is 3. Set this up using the formula, which, just to refresh your memories, I'll put to the left here, so you can see that. N factorial over n minus r factorial times r factorial. Okay, so 5 factorial over 2 factorial times 3 factorial. Right, time to do a little bit of expanding and cancelling. So 5 factorial, 5 times 4 times 3 times 2 times 1. 2 factorial, 2 times 1. 3 factorial, 3 times 2 times 1. So we can get rid of these. And what we're left with is 5 times 4 over 2 times 1. 5 times 4 over 2 is 10. Now that's a vastly smaller number than we came up with in the permutations video, where it's unimportant that we limit this to AB equaling BA or whatever. Order is important for permutations, it's not important for combinations. Okay, so that's an introduction. There will be some examples of this in the rest of the playlist. Once you feel that you've got your head around the difference between combinations and permutations and you're familiar with factorials, maybe have a look at some of the examples. It does take a bit to get your head around probability. Thanks very much for watching. See you next time.